Hey everybody, just wanted to spend a little bit of time going over Brown, LeMay, Burston, Chemistry of the Central Science, question number 20.19. Okay, and so here it says which of the following is oxidation reduction, and then it says just identify the elements that are undergoing changes in oxidation number or oxidation state. So we can do that. Okay, the easiest way to do that, and I know that this is going to seem like a lot of work, but until you get good at seeing this, I think it really helps out your understanding. And so let's list all the elements: P, Br, H, and O. For part A, so we have P, Br, H, and O. And so that means they're going to be over here. Okay, so as a reactant, I'm going to make a column, and then as a product, I'm going to make a column, because I'm just going to do this. Now, you can always determine the oxidation number, oxidation state. That's what this is basically asking. Okay, so here the oxidation state of phosphorus is 3+. And in this case, let's see, because oxygen is 2-. Okay, so there's 6 of them, so that's 6-, and this is 3+. So to even out, that means that phosphorus is not going to change its oxidation state. Now that's a good sign. Whenever you have the atoms that aren't common in redox reactions, like atoms that are common like hydrogen and oxygen, and they stay the same in terms of oxidation number or oxidation state, that's usually a good sign that it's not going to be a redox reaction. Okay, so now we look at bromine. Bromine is a 1- or -1, and here it's a -1, so that's good. Okay, and so hydrogen is a +1 here, and it's a +1 on this side, and oxygen's the same thing. Okay, it's not the same thing as hydrogen, but it's the same thing in that it's not changing. Okay, so this one is not a redox reaction. Okay, I need a little space here to look at this. So let's look at question. Let's look at part B, and we'll do the same thing. So we're looking at NaIHO and Cl. Okay, and we'll have the reactants in one column and products in the other. So let's see here. So the reactants, sodium and sodium, they're both combined. Sodium always, when it's combined, is a 1+, so that's a good sign again. Things that are not hydrogen and oxygen seem to not be changing oxidation states. Okay, now let's look at iodine. Iodine, when it's bonded to one other element, is going to be a 1-. Now here, it's going to be a little bit different. So let me pull up NaIO3, and oxygen is 2-. Okay, almost always, except when it's with superoxides or peroxides, or when it's bonded to fluorine. But 98% of the time, oxygen is 2-. So let's put that down here, 2-, and actually it's 2- here. But again, that's not indicative that there's a oxidation reduction reaction. We just don't know yet. Okay, and so if that's 2-, that means we have 6- total. This is 1+, so this is 1+, so we need all of this to add up to 0, so that means this iodine is 5+. Okay, so yeah, that definitely has lost some electrons. That's what's being oxidized. Okay, so now it's on the hunt for something that's being reduced, and 99% of the time, it's not going to be the hydrogen. In this case, it's definitely not the hydrogen. Hydrogen here is a 1+. Hydrogen here is a 1+. It's only it's a 1+ whenever it's bonded to almost anything, except for when it's a binary compound bonded to a metal. So like something like sodium hydride or potassium hydride or something like that. Okay, and that's not these cases. Okay, so the only hope we have here is chlorine. Okay, so my guess is that is going to help us out. So chlorine, over here, chlorine is a 1-. Whoops, I was going to write 1+, but that's not right. Okay, 1-. But over here, let's see, this is a 1+, oxygen is a 2-, So chlorine here has to be a 1 plus, so that's the thing that's being reduced. So yes, we already knew that this was a reduction oxidation reaction. That's fine, but what we didn't know is which two things were being reduced and oxidized. The thing that was being reduced was the chlorine. The thing that was being reduced is the oxygen. The thing that's being oxidized is the oxygen. Okay, so let me get a little more space and let's take a look at part C of this question. Okay, I thought I was going to be able to put it right here, but let's do this. Okay, so let's take a look at part C. So again, let's just list the elements. There's S and O and H and N. Okay? Okay, so I'm going to focus again because hydrogen and oxygen so very rarely change oxidation states unless you're going to form their element. That I'm not going to focus on those first. I'm really going to focus on sulfur and nitrogen first. It's a good kind of handy dandy little tool to help us. Okay, so sulfur. Let's see, as it in the reactant and in the product, if I can write that correctly, product. Okay, let's see here. Sulfur. Okay, so here oxygen is always a 2 minus, so let's write that down because we already know that. Okay, and then that makes sulfur a 4 plus. Now in the products, it's still a 2 minus, but now it's a 6 plus. So yeah, we know that sulfur is being, in this case, oxidized. Now, in terms of reduction, this is kind of an interesting deal. Hydrogen, let's ignore hydrogen and just look at nitrogen because that's my guess. So when we look at nitrogen here, again, oxygen's 2 minus. There's 3 of them. That makes that 6 minus. And this hydrogen is 1 plus, and we're ignoring the coefficient there, so that's 6 minus and 1 plus, so that makes the nitrogen a 5 plus there. Now when we look at it over here, NO, okay, well, oxygen is 2 minus, so that means that the nitrogen is 2 plus. And so that means that this is what's being reduced. Okay, so there you have it. Question number 20.19 in Brown, LeMay, and Burston. So have a great time.